Today, you're gonna build your very own interactive Tetris game in Python using Pygame, bringing all the fun you know and love of Tetris to your fingertips through code. In today's episode, we're gonna build on your understanding of object-oriented programming, as well as your key understanding of data structures in programming. Guys, all this is going to be done through interactive lesson material, as well as live hands-on coding for you. If you guys are ready to take your programming up a level through advanced game development, this is for you. Welcome back, guys, to another episode of Code with Josh. Whoa! Welcome back, Python crew. For obvious reasons, I'm Josh, and this is another episode of Code with Josh. Before I dive into today's a little long episode, do me a favor, click the like button and subscribe, as that really does help me, a small growing channel of 7,000 subscribers now, reach more students around the world. Today's episode is a little bit different. It's a longer episode, and I've broken all this down to hone in on your understanding of object-oriented programming, working with classes and objects, as well as data structures. Guys, in case you missed it, all right, I have my 3 free Python courses, absolutely free. It's the link in the description, all right? That's meant to help take you guys from A to Z, or at least from 0 to knowing. And in there, I do break down in a structured manner, not only Python, but I have Pygame projects if you dig this, right? Last week's episode, if you're coming from that, we did PyPong with pure Python and a little bit of Pygame, right? This project of Tetris today is meant to build on that. All right, guys, enough chit chat. Right, I think that's all I wanted to say. If you like the video and you like the content, let me know in the comments, all right? And check out the links in the description, all right? Most of them are free. It's all the resources I have available to you guys. There are a few paid links in there, like my premium newsletter, a few other affiliate links that do help support the channel. All right, so enough chit chat, over into the interactive lessons I've made for us. Here we are, guys, in our Tetris in Python. Now remember, this is a slightly advanced Pygame project. I'm not going to go into the immediate details of Pygame itself. If you want to see that stuff broken down, head on over to last week's video or my free Python course where we do go through Pygame. All right, so today's all about Tetris, all right? And this is kind of the timeline that I have mapped out for us, all right? So I like to break projects down into phases, and that's how you should be doing it too. We want to go through step 1, which is really just our initial setup, getting the constants we need in order to create the game. Step 2, we will begin to use our OOP skills to create a class for each individual Tetris shape, right? So not 1,000 classes, right? One class that represents a Tetris shape. And then we have our main game class, which will be the next phase. Once we have the interaction and the creation of objects, we can focus on our events. What can we do? How can we program our shapes to do stuff, right? Once we have these first 4 steps, that's really the whole Tetris game, right? But a game, we should have the ability to have points and levels, which is step 5, and that will bring us to our final design as well as any final dashboard touches we need for our game. Let's take a look at our game here. So if we bring this into play, we are trying to create a fully interactive Tetris game, just like the game you know and love we're doing here in Python, right? So we want the ability to see the next Tetris block, right? This block down here at the bottom, that's the next shape that's going to appear. We want the ability to earn points every time we delete a row. We want the ability to level up our points after we collect so many, right? So this is the game's output, right? The overall game, we have a Tetris game class, and then the shape class will correspond to each individual shape. Now, how can we do this programmatically? So I want you to think here, you see a grid, right? All this grid stuff in the back. How could we create a grid in programming? Okay, so I'm going to show you a quick picture. I'm not going to touch on it much, and I'll go back to it. All right, So think about the data structures you know. How could I create like, ever play the game Battleship? You know, like you have a game and you put 6 ships and then you call something out and it's either a hit on your opponent's board or it's not. It's kind of like Battleship. What if we created our own grid? And we could do that through a list, right? So what if each row was a part of our grid, right? And we could code this programmatically and then give this program almost like a GUI, an interface on top of it. Okay, let's start with our shape class, okay? The shape class really just corresponds to an individual shape, okay? And the ability of this class is not very much because it's only referencing a single shape, right? It's gonna create a shape. Well, no, it holds all the shapes. So it holds all the possible generations of a shape and all their orientations. It has the ability to randomly select a shape and the ability to rotate that shape, okay? So now, just going back previously, right, how will we create a game board and use coordinates to target each block of our Tetris shape? That's what we need to keep track of. We are going to do this through a list, right? So our game board, we need to create a game board, and that's what we're doing here in the first step. And this game board is essentially a list of a bunch of zeros. And you can see now that when I have a shape, we aren't going to have zeros anymore, right? This corresponds to our shape, all right? So for example, if there are 4 Tetris colors, blue, orange, green, and pink, right? 1, 2, 3, 4. Depending on the color, that's what we are going to see here on the coordinates of our screen. Right? So in this example I'm showing you, 2, it represents the pink blocks, right? Maybe if this was all 1, this would be blue blocks. That's going to give us the ability to save what image is where in our game. This Tetris class does a lot. We create a grid. You can see the grid, the lighter blue lines I have here. We have the ability to create new shapes, always checking for collisions. What can we collide with? We have the ability to remove a row if it's all completed, right? We can move down, left, right, end the game, all that fun stuff. All right, we need the ability to create a method for each of the tasks above. That's a lot of methods. All right, so I count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 methods in our parent class. All right, guys, I've broken this down in a way that hopefully can showcase what we're going to be doing today. I want you to drop me a comment. How do you feel going into this project? And I want you to let me know how you feel at the end of it. All right, I'm really hoping that we can build on all your current knowledge to take your Python skills up a level. If you guys are ready, do me a favor, right? Like and subscribe. We're about to dive into VS Code. Let's do it. All right, guys, cool. Here we are in VS Code. You can see I'm doing this a bit different today, right? I got me down in the bottom left, all right, and I'm going to code out as we go along. So use the timestamps I have for you guys, all right? But how I want to start this project is I just want to write pseudocode. What am I doing? Each step of my thought process, and we can go through and code that out together. All right, so I'm just going to go top to bottom, right? I'm going to have all of our imports, right? We are going to have our constant variables. Okay, so what variables will not change in our game? We are going to have our game settings. So this is going to be things like our game screen, the clock, title, etc. Right? What do we need to get started with that? What other variables will we need? So I'm going to have my colors. Whoops. Comment that. Okay, and you guys can structure this how you guys want. I'm working top to bottom. This is how I visually just work through a project, a game. At the end of this episode today, all right, I could structure this into modules as well. We'll see how we get on. So our colors, okay, I do want to load / store my pictures somewhere. Okay, so we can have that stage. Great, and then we're going to have our fonts. So this is all the initial generic stuff, right? So now moving forward, I can start to build out our classes, let's say. Speaking of classes, we are going to have one class for our shape, right? So I'm going to say, yeah, shape class, all right? This is going to be responsible for creating a single shape on the screen. Great. Now, the only two methods in here, okay, we are going to have our constructor. So what do we need to build our method? We are going to have an image method. So this is essentially going to show us or choose the correct image. So I'm just going to say choose correct image. Whoops. Okay. And then finally, we will have a rotate method. So this will give us the ability to rotate one of the shapes. All right, great. So my shape class is done. And then coming down here, I'm going to have like a game class. This is going to be the main game class, which is responsible for sort of everything, right? When I fire my game, this is what's going to be responsible for it. So we'll have our constructor. We are going to have a grid. So I'm going to say like make grid. We're going to have one that's going to make new shape. Okay, so when I start the game, I need to make a new shape. I need to make the screen, the board, the grid, all that fun stuff. For now, I mean, there is a lot more to the game class. I'm going to kind of just leave that where it is. Let's just get things set up and going first. All right, and then down here, right, we would have our main game loop, essentially. Okay, so this is what I want to begin with. All right. All right, this is wonderful. So I'm going to go up top here. Let's begin with our imports. What do we need? Well, we're working with Pygame, so I'm going to bring in Pygame. And I'm also going to be using random for this, right? Because I want to choose a random shape for Tetris, our game. Okay. Once we've brought in those two, I do need to say pygame.init to activate Pygame. It's key to note here, I am not saying from Pygame import star. This game is too big now. All right. If you're coming from our last week's game, we did PyPong. And I just said from Pygame import star because it was a smaller application, a smaller project, easier to work with. In a larger game like this, I'm going to keep with import Pygame. It's going to allow me to register where things are coming from in a more fluid manner. So let's begin with our constant variables. So what are things that are never going to change? Well, I'm going to make these in caps, right? So width and height. Okay, for this, I'm going to say the width of the game is 300 and the height is going to be 500. We'll create an FPS. I'm going to put this at 35. That's the sweet spot for me right now. And then a few other ones we're going to build out. So if we imagine, I'm going to put the picture here on the screen, that each block, right, I can't move pixels. I can only move the blocks. So I'm going to create like a single block. Will be like cell. And this is going to be equal to 20. So each block is essentially 20 pixels. Now, based on the width and height of my screen and how big the cell is, I can essentially create rows and columns. And to create the rows, how do I find out how many cells go into the width of the screen? Well, okay. Let's take our height. Excuse me, I don't know why I'm taking height there. Let's take our height. Okay, if I can spell height correctly. I'm going to subtract 120, right? Because that small place on the bottom of our screen, I need space for that. And then we're just going to divide it by our cell. That's going to give us the number of rows we're allowed to have in our game. And the reason we're doing this right is because if I decide to make the game bigger, this is going to change dynamically as our game progresses. And then for our columns, I can just take the width and we can divide that by our height. Nope, sorry, cell size. Okay, so awesome. These are going to be the constant variables in my game so far. All right, our colors will also be constants, of course, but these will be affecting the outcome of our game. Now, our game settings, we need to get a game screen set up here. I like to call it screen. That is a constant for me. We are going to say pygame.display.setMode. All right, now set mode can take a few arguments, but the size of your screen is a single argument. So I have double parentheses, and I can pass in here our width and the height of the screen. Great. I'm going to create a game clock. This is really just responsible for our FPS. And I'm going to tap into the Pygame time module. This is not the Python time module. This is from Pygame. And this allows us to work with that FPS. Okay, there are other ways to do this, guys, right? So like, I don't need a clock. This is just how I structure the game. Okay. And then finally, if you wanted to give your game a title, I could say Pygame display set caption. Inside here is you'd put a string of like the name of your game, Tetris. Awesome. All right, I'm going to keep going now. All right, so if you run, I'm not going to get any errors, but nothing's going to occur on the screen because I don't have a game screen. I don't have anything yet. We're not at that stage, right? And you can see, hello, Pygame community, right? So nothing is happening. We need to actually create a game screen, which we're going to get to. Let me finish out these constants here. Okay. When it comes to colors, right, you can bring in as many colors as you want. I like to bring in extra colors so that I can play with these and alter them later. So in my game, I'm going to have, all these colors I'm making for you here. I'm going to have a black and white, so text and anything else. I like to have those two. Background color, the grid, if I win and if I lose. Yeah, okay. If I want to add more colors later, I can. A color in Pygame is a tuple, okay? And it is an RGB color, so red, green, blue. Now, for white, we add all the colors, and the maximum number is 255. And for black, it's all zeros. The other ones I'm going to drop in because I already have them. All right, cool. So my background color is a bluish color. This becomes a slightly darker blue for the grid, okay, because I don't want it to be like eye-popping, eye-hurting. Win is going to be a greenish color, and then red is like lose is like a reddish color. Okay, cool. This is great. So let's see here. We are going to load and store our images. So I'm going to create a constant actually. This is going to be our dictionary, assets. Okay. Now, inside assets, I do have a folder over here called assets, and it has all of our pictures in, right? Remember, you guys can get this down below, okay, over in the repo. And I basically want to quick access these. So what is a data structure in Python, which would allow me to store these pictures as a value for quick access? A dictionary. All right. So inside here, I'm going to create a key as just one. There's 4 pictures. And then as the value, I'm going to tap into Pygame image.load. I want to load a picture. What do I want to load? I'm going to start with the folder, assets, and then one PNG. Okay. I can ideally just copy this one because we're going to use that a lot. We're going to put 2, 3, 4. Just like that. Just make sure you go through and we do change those. We won't use these for a while, but I want to bring them in now. Okay, we have them. Great. All right, we're almost there. The final thing I'm going to do here is I'm going to make 2 fonts. Font 1 and font 2, right? Font 1 will be a larger font we can use for score, for the levels, all that stuff. I can say pygame.font. I'm going to access a system font because I'm going to use a custom one. There are other custom ones. Not all of the ones work on here. So like if you use Canva, right, or Google Docs, not all of those are going to work, but a lot of them do work. And just by heading over to the Pygame documentation, you can find this out in a minute or two. So I like to use the one Verdana. I'm going to put that one here. I know it works. And this font can have a font size of 50. The other one's going to be the same thing, but I'm just going to tweak this to be like a smaller size. So let's say like a 15. Okay. This is amazing. So all of our initial game settings are ready to go. It's all set up. I'm going to go down to the bottom and get our kind of loop going. I'm going to structure this though in a main function, right? Because I want to, a modular effect here. We'll create a function called main. And really all I'm going to do for now is I'm going to create a variable here called run equals true. By doing this, when I say while run, it allows me to switch the game on and off. This is a flag variable. A flag variable is a variable that's value is a Boolean, true or false. It's like a light switch. Turn it on when you want it, turn it off when you don't. Okay? So while run. Very straightforward. I'm going to, let's take our screen and I'm going to apply the fill method and we can give our background color, okay, to the screen. And then the last two lines of any Python Pygame loop is going to be Pygame. I want to take the display, which is my screen, and I want it to update every time the loop runs. And then we created a variable up here called clock. I want to use this, okay? So clock actually takes our FPS, just like so, all right? And in order to give this a quick try, let's say if name is equal to our main, then we're just going to say main. Okay, that's our function that we just made. Let's run this. Cool. So I'm not getting anything. I'm going to do a quick fix for that. So it's showing me this open, but my screen didn't open yet. So I'm just going to give it a quit command really quickly. I will explain these events as we progress on, but for now I'm going to say for event. So for every event in Pygame. Now, very briefly, what event could happen on the computer? Stop. In English, what does the word event mean? An event is when something happens. A wedding, a birthday party. Well, what's an event on the computer? What could we do? I could press a key. I could click the mouse button. I could quit, right? All of those are events. So I'm tapping into Pygame's event. Let's call it a dictionary, right? They have all their events here. And really, I just want the first event. So, oops, not for. If the event.type is equal to a pygame.quit event, I'm just going to say run my variable, my flag variable is equal to false. Okay. As a safety net, I am actually going to go to the top here. I'll type it now real quick. I'll say system.exit. I'm going to go to the top and I'm going to import system. Okay, so import sys. This will just help us close our game. Okay, so I'll go down here so we can look at that. Okay, here's what I got so far. I'm going to try this again. Let's close that. Let's run this. There we go, right? So I have nothing. This is just my Tetris screen, right? I have my close button, which we're going to actually take away later, but this is for the building out part and then our name of the game. Okay, so we're pretty much ready to go. All right, so let's close this down here. Let's go to the top of our code. Now that we pretty much have everything, I'm actually just going to go and we can begin our first class. So I'm going to give a lot of space here because I want us to stay focused on the actual topic at hand, which is our shape class. So we have two classes. This class here is solely responsible for choosing a single Tetris shape, okay? Now, the funny thing is, right, is if you've ever played Tetris, for coding purposes, every Tetris shape is a letter in the alphabet, right? That's it. It's literally a letter in the alphabet. Okay, so look at all these Tetris shapes. How could we make these as a letter in the alphabet? Think about that, all right? I'm going to come here. I'm going to create my class, shape, all right? We're not really inheriting anything. I'm going to drop in two constant class variables, okay? So let me explain these, okay? And I'm going to explain them as we go through because I need us to understand these, all right? Because it'll make the rest of the process easier. Now, what types of data do I have on the screen? Well, version is a dictionary. It is a dictionary containing nested lists. And then shapes is a list of strings. Okay, so shapes represents each different Tetris shape we could generate. These are all the pictures we have here on the screen right now. Okay, then once I choose a shape, the other version is the version of the shape. Right? It's the orientation of the shape. So for example, if we take the shape I is like a line. if I rotate that, how many times can I rotate it? 1, 2. That's it, right? There's only 2 versions of that shape. So I has 2 lists, version 1, version 2, okay? If we go to L, how many versions of L are there? There's 4 versions of this. Each of these inner child lists represents a single version of that specific shape. Okay? So these inner numbers, for now, all I want you to worry about, these inner numbers are not important to you, okay? I'm going to let you, it's in the repo below, but these inner numbers represent roughly coordinates on our Tetris grid that's going to form the shape, okay? So I have a dictionary. How do we access a dictionary? Dictionary key unlocks a value. And then how do I access an element from a list? Index, right? And so this project is going to be great because it's really going to get you comfortable working with data structures. I'm going to create my constructor. So this is our init. What do I need to know about each shape? Well, really just the X and Y position, okay? All the other stuff here I can generate on the fly. So we can say X, I'm going to make a property for that. We'll say Y. Let's give more space here. Okay, now I'm going to create a few other things. Let's just make them here first. There's going to be a type of shape. There's going to be the shape itself. We are going to have the color of the shape, and then we're going to have the orientation of the shape. All right, so let's begin with the type. I just want to choose a single shape from here, a random shape from this list that I can build out going forward. So the type of shape, let's use random. And random has a method, a function called choice. Choice allows us to choose a random item from an iterable, a list. So I'm going to give it my list. We're going to say self.shapes, if I can spell correctly there. All right, so now ask yourself, what is the value of this property? What type of data? The answer is a string. It's going to be one of these items inside shapes. Okay, so now that I have one of these shapes, I now want to get the orientations, the versions associated with the shape that I'm trying to create. So remember that shape, self.type, is a string. It is going to be a key in our dictionary. So now shape, I'm going to take our dictionary, so self.version. How do we unlock it? I'm going to put self.type. This is going to return to us one of those nested lists, of the list, the whole thing. All right, cool. Now, how can I choose a color? Well, there's 4 different pictures. We just have 4 different colors in our game. So I'm going to choose a random color, random, so random.random, choosing a random integer from 1 to 4. All right, wonderful. And then lastly, orientation is equal to 0. I want you to process this for a second while I drink my water. All right. So think about this now, right? The orientation represents how the shape is. So let's take L, because I can do that here. If I have L, and this is the starting position, it starts at 0. 0 is going to be the first list in our nested, our master list. If I rotate it, I could say self.orientation is now equal to 1. Boom, I turn it. It is going to be the next list in our dictionary nested list. All right, so this is how we're going to change the orientation. Awesome. So we've created our constructor. I'm going to create a method called image. And image is just going to return to us our shape. Now, what is self.shape? Right now, the type of data, what is this? This is a list. It is the main parent list. Let's get an inner list from the parent. So square brackets, how do I get the inner list? What is affected by that? Well, like I said, my orientation. Okay, so this is going to return to us a single child list. Which version of the shape is it? So I can be like, let's say, version of the shape. Okay, cool. And then the last one is going to be called rotate, right? So this is going to give us the ability to essentially rotate the method if it's possible. So really, I just want to update my current property rotation when I call this, because I'm going to go self.orientation is now equal to 1, 2, 3 every time we rotate that shape. To find out if this is even possible, right? Because with O, that's a square. If I can't rotate a square, it's the same thing. It's a square. So I need to find out if it's possible. To do that, I'm going to say self.orientation is now equal to self.orientation plus 1. I'm adding 1 to self.orientation. That's all we're doing. But I'm going to find out if it's divisible by the length of our master list, right? So our remainder of the modulo, right? Because if I only have 1, I mean, it's not possible. I'm not going to change the orientation. It's going to stay at 0. Okay, so this class is actually completed, right? This is responsible for a single Tetris shape in our game. That's awesome, guys. All right, pause the video if you need to. Take a minute to process what's happening here. It's important that you can go through and answer specifically what each type of data this property holds and what it's responsible for. Okay? It's also important that you understand this image method, right? And how each list represents a single orientation of the specific shape. So I'm going to unmark these now. I assume we got that. Okay, I don't even need this open. I'm going to go down. So we are now going to go down. Let's bring this up now. Okay. We can focus a little bit on the game class. This is huge. All right, so I'm gonna begin with this. I just want you guys to see like the Tetris grid appear, and then we can start to actually put shapes and create those on our screen. So I'm going to create a game class. Let's literally call this actually Tetris. This is responsible for everything, all right? And inside here, we're going to create our constructor. And what do you think we need to know to make the game? Well, I need to know, let's say like rows and columns. Okay, I could change this later, but how many rows, how many columns are there for the game? So we can create those now. Rows is equal to rows. Calls is equal to calls. Okay, and there's a lot of other stuff, so let's put that here. So I'm going to say we could have a score in the game, right? We could move up a level in the game, all right? We need a grid, right? So you can think of this as the game board in code, all right? But I need a grid that's going to really structure our game. I'm going to create one called next. This is going to allow us to access the next Tetris shape in the equation. I'm going to create one called end. And end is going to be responsible for like, is the game over? Has it ended yet? All right, so end initially, is the game over? No, this is just going to be a Boolean. The game is not over. False initially is none, right? Because I have not created a shape yet. There's nothing there. Score can be 0, and our level can be 0. Now I saved the grid for last, right? So how we're going to create a grid here is really, it's just a grid of zeros. Right, so if we imagine our Tetris game, each cell is a 0 the whole way across, and then each row are also zeros. So what's a quick way we could do this? Lists, right? I want to make a list that is just multiple lists of all zeros that we can alternate later. So to do this, let's create, you could do this not a comprehension, but it's faster. I'm going to create a list comprehension. What is going to be the element in the list? Each element is going to be a list. So I'm putting a list in a list. Now in the inner element, we're going to have a 0, and I'm just going to say for j in range for the number of columns we have. Cool? All right. How many times am I going to repeat that? This is like the rows. For I in range, rows. All right, so this is ultimately a hugely nested list of a bunch of zeros that we're going to use for our grid. Speaking of the grid, you can't visualize all zeros in a Pygame. I want to see the lines because, right, if I run my game, it's just a blue screen. So let's make one called Make Grid. All right, and to do this, we're actually just going to say Pygame, I want to draw a line, right? And what do I want to draw? Well, I'm going to have to repeat this a lot for each column as well as each row. So let's loop, right? I can use a for loop to repeat when I know exactly how many times I want to repeat something. So if I say for I in range, how many times do I want to repeat it? Well, if we start with the rows, I have my property, self.rows. Let's make sure we add 1 to it. Python starts on 0, right? And then I can draw a line every time. Okay, I'm gonna copy this because we can also use this for columns. Let's just change row to say cos, and then also don't say I again. I'm gonna say J. So for each row, where do I want to draw the line? On my screen. What color is it going to be? I have a color called grid. Okay, that's like a dark blue. Or a lighter blue for me, actually. You could use white, but that's really hectic on the eyes. So I'm going to say now I need the starting position. Where is it going to start? Well, it's going to start at 0, as well as my cell, which is 20, times I. Okay? And then where's the ending position? Well, we're going to go to the width of the screen, right? But we're also going to make sure we go to cell times I. Cool. That's awesome. Okay, for the next one, it's relatively the same thing. Screen, grid. This time, we're not going to say that. We're going to say cell times J, 0. And then for our other one, we can do cell times J. And I'm going to subtract 120 because that's the space on the bottom of, wait, no, I'm not. Height minus 120. That's the little space on the bottom of our Tetris screen. Okay, wow. You know what? Let's go down. I'm going to make an object very quickly. Let's pop in here. I'm going to create an object called Tetris equals Tetris. For now, it says rows and columns. I'm just going to say like 5 and 0. Okay, it doesn't really have any effect quite yet. And then in here, let's just say tetris.makeGrid. Let's run our code and let's see the output of this. All right, so here we go. Now, I wanted you to see this, right? So why are there only 5 lines? Well, right, because I told it to. I said 5 and then there's 0. Whoops. I don't have any columns. So let's take our class. We made 2 constant variables called rows. So we did the math to divide that, and we also have columns, right? So now when I trash this and run this, you're going to see the nice grid. You can keep this or remove this depending on your play style. But this is the actual output of our game, all right? Down here in the bottom is where the next Tetris shape will show. I'm going to have a score as well as the level, all right? We are really ready to get going now, all right? The initial structure is done, okay? The next thing I'm going to do here is I'm going to head back up to our Tetris class, okay? And I ideally want to like spawn a shape. So when the game starts, I want to spawn a shape. So I'm going to create a method called new shape. This will be used multiple times as well, right? So this is just responsible for spawning that shape. Now the first thing I need to do is make sure that is this none? Because if it is, I am then creating the first ever shape. Okay, so I'm going to say if not self.next. Okay, so if there's nothing there, then ideally I want to assign it a value. And we're going to use our shape class that we made. Now, what is the X and Y starting position of the shape class? I'm going to put it in the middle of our Tetris grid. So 5 and 0 is at the top. All right. So I created the next object. All right. Now I'm going to use this later to constantly check if there's another shape available, but that's going to be for a different purpose. So now going forward, I'm going to create a new property right here called self.figure, and the value is self.next. Okay. So I'm going to come back to this really quickly. If that was not none, then we're just creating a different shape. Okay. This is so very important, okay? Every single Tetris shape on your game screen is called in our code self.figure. So anytime you want to do something with it, you want to get the X position of the current Tetris shape, that shape is known as self.figure. That is what I've called it right here. Okay, the value of this, it's holding one of our shapes. So really this is an object. Right? If I go up to my class, because it's an object, I can access the X and Y at a later stage, as well as the color or anything else we made here. Okay, that's pivotal. That's key. All right, let's go here now. So now, immediately when my game starts, this class is my game. Init is automatically ran. So I'm going to say new shape. I want it to create a new shape immediately when we run our game. Let's see what we're given. I'm going to run it. Okay, so we're not displaying anything yet. That's perfectly fine. All right, but we're still bug-free. We're calling everything out. Now, to get it to show, let's go to our loop, right? So every time the loop is running, ideally, I want to constantly be displaying the shape on the screen. So we can go down here, and I need to loop through every column as well as every row. All right, so I'm going to put this right here. So I'm going to be like show shape on game screen. So I want to go through all the rows. So I'm going to say for I in range, we're going to say rows. At the same time, we want to go through all the columns. So in range, cols. Okay. And basically, I want to check if I times 4 plus j, okay, I want to check if the number is a number in our list. So this will make more sense here in a sec. If we take our figure, tetris.figure, remember, what is self.figure? And I'm going to call the method we made image. What is this? What is happening? Okay, so I'm looping through all the rows. That is I. I'm looping through j. And I'm saying row times 4 plus j. This results in an integer. Okay? I'm checking if this integer is an integer of our figure. If it's an integer, if I go up, I'm checking to see if it's an integer inside of this list. Okay, that is what's being checked. If it is an integer inside this list, it means it is a shape indeed. Okay, and I should be displaying that on the screen. So if we return now, I'm going to see this a lot today. All right. Now that we know this, let's create an actual picture. So image. I'll actually say shape. Okay, so I'm going to create a shape. This is going to be a real picture. How do we access a picture? Well, remember I have a dictionary called assets, and I want to get one of the pictures from that. So really, I'm just going to say tetris.figure.color. Remember, this color is an integer, a random integer between 1, 2, 3, and 4. So this is going to choose a random color for us. Shape is a real picture from our list, right? So it could be this one, for example. All right. Great. Next up, for that shape will need an x and a y coordinate. Right, so where is the x of the shape going to be? Well, ideally, it's going to be roughly at the top of the screen. So I can say cell, right? We're not doing pixels here. Each square represents a single cell, times our Tetris figure x position plus I. Okay, the other one's roughly going to be the same, but we are going to change it to say y and then plus j. Okay, so we have the picture, we have the location. How do we get a picture on the screen in Python? Blit. All right, so I'm going to take my screen and we're going to say blit. What do I want to blit? my shape. I want my shape to be pasted on my screen. Where do I want it to appear? Well, X and Y, just like that. All right, now this is going to be a little picture, right? And in order to register for collisions at a later stage, I need to create almost a hitbox around this picture. So in Pygame, to create a hitbox, okay, I want to draw a rectangle, a rect. This is going to be like an invisible rectangle behind the picture that we won't actually see. I'm going to say screen. You could put any color here, white. Okay, it's not going to affect too much. And then we're going to say the X and the Y is the rect value, but I'm going to make sure that it keeps the width and height of the individual cell size. And then finally, the width, we can give it as 1. Okay, this is great. So I'm going to try and run this again. All right, so well, we see stuff. That's great. It's not the exact shapes we want. That's fine. All right, I can tweak that later. And you can see here, right, well, they're not moving for obvious reasons. We're just blitting them on the screen. That's what I've done here. I've just blit. You know what? This is kind of weird. If I change, if I say X plus J and we say Y plus I, is that going to change the shape's orientation? Okay, well, that did something. I'll keep what I have now. So I swapped those. All right, I'm gonna tweak the shapes at a later stage. All right, this is great. So we have something ready to go. It's now time for the next step, right? It's time to basically get these things moving on our screen. All right, so let's go up. I'm gonna carry on here. Now we got a lot more to do. So we need a method. Whoops, I'm in cap lock. Collision. I'm still in cap lock, whatever. I need a method to check for my collision. I need a method to remove a row, right? So if we get a complete row, it needs to remove it, right? We need a method which is going to allow us to move down, move left, move right, as well as actually rotate the shape. Okay, so I'm going to actually start with collision and move down because we want the block to start falling down. So let's create a method called collision. And really inside here, I need to loop through everything and check if our number has collided with the bottom, the sides, anything like that. So we're going to say for I in range of 4. We're going to say for j in range of 4. If we're going to do that thing again, I times 4 plus j, right? Because that's going to return to us a number. And what are we going to do with that number? Well, we're going to check to see if it's in our self.figure.image. Okay, so if it's a number in our list, I'm going to create a row and we're going to create a column for that block. So I guess row block, row, block call. Okay, so your block row is going to be I, and we're going to do plus self.figure.y. And we're going to copy that, paste that. We can say j, and we're going to put x here. Okay, so we have a row and a column. Now, really, this method, let me just be more specific, actually. It's going to output a Boolean. Okay, that's for you guys. All right, so this is going to be used in conditions later. And this is just checking every time we call this if one of the blocks in the Tetris shape has touched another block or the side or something that it shouldn't. All right, so really I'm going to say if here. And we're going to say if our block row is greater than or equal to self.rows, so we've gone too much, okay? Or our block column is greater than or equal to our self.columns, okay, that makes sense. We have two more, right? Or our block row is less than 0, no good, okay? And our last one is going to be or our grid. So remember, we made our board right here, our grid. Okay, this is going to be one of them. So if our grid And how do I get an element from that nested list? We're going to say block row is going to be our first one, and then block col. So why am I doing this one? Well, if that is greater than 0, this itself represents if the Tetris shape has touched another block, right? Because we know that the grid is made up of all zeros. If it is not a 0 in the grid, right? So it's greater than 0, it's going to be picture 1, 2, 3, or 4. Okay? Okay, so if that returns true, then I'm going to return true. All the way outside here, let's just say, no, I don't even have to say that. Just all the way outside, I'm going to return false. Okay, so it's not true. There is no collision yet. All right, this is great. Okie dokie. Okay, so collision is a Boolean, right? Let's try to get this shape moving, shall I say. Let's do this. Let's create a method called move down, okay? And really, how do we move a shape down? Well, we're going to take our figure, which is our self. We're going to say y. Pygame's backwards, so I'm going to say plus equal 1. Now, this is not one pixel, it's one whole block, one whole cell. All right, so every time we call this method, it's going to allow self figure y to move down. But while it's moving down, we constantly need to be checking if self.collision. Right? So if the function we just made is true, what does that mean? Well, it means we've had a collision. So if we do have a collision, we are just going to take our figure y, and we're just going to minus equal 1. So it just stops it in its location. All right. Okay, let's go down to our loop here. So, right here. I'm going to create a few things. So let's create a few variables here. Let's say counter is equal to 0. Let's say move. Do I have that yet? Yeah, move is equal to, let's say move is equal to true. Okay, so I'm allowed to move at the start of the game. Okay, nothing's telling me otherwise. Okay, so in here, let's say every time our while loop runs, I'm going to take the counter and increment it by 1. This is going to allow our Tetris block to fall at a consistent rate how Tetris should. Because in a game, if I don't do this, the block will just go very steady. But Tetris, it goes ch, 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 right, like that, falling. So count plus equal 1. If counter is greater than or equal to 10,000, if you wanted the block to fall faster, you would put 5,000. If you wanted to fall slower, you would put 15 or 20,000. Okay, I'm just going to reset the counter. Okay, so I'll put here for us, allows block to fall at constant rate. Okay, cool. Then really the only part, I hope, without error free, that we need to get going here is I'm going to say if move is true. So if I'm allowed to move, what do I want to happen? Well, I want the block to begin to fall. Okay, so the block can only fall if my counter, right, I'm going to say remainder of FPS divided by our Tetris level. So as the game gets harder, right, it's going to fall faster. Okay, so we'll say our FPS, we decided that earlier, and then our Tetris level. And if that is equal to 0, the block can fall. I'm just going to make sure it's not the end of the game, so Tetris.end, right? And if it is not the end of the game, then we can just say Tetris.move down. Okay, I'm going to expand on this chunk here later. Fingers crossed, let's run. If I haven't missed anything, we should be good to go. Okay, so boom, this is fine. Errors for days. Okay, so the error, right? I mean, yeah, I'm dividing by 0. That makes sense because I think I said level 0. We start on level 1, right? We start on level 1. Let me try that again. Boom. Okay, so I have 2 shapes. I need to resolve this. All right, but you can see the shapes are falling. This is great. I can't move them anywhere. All right, and when I hit the bottom, it should cut out. Okay, so it freezes. that's fine too. All right. We do need to freeze them for the next shape to fall, but we're good to go. Let me figure out why we got this going on. So I like to just go to the top, and I'm just going to work top to bottom. I'm just going to go down here quickly. All right, so, I mean, all this stuff is fine. So it's generating two shapes. All right, so all of our constants I know aren't the problem. The shape here, well, this is for one shape, so we know it can't be that. Let me check this one. So if not next, self.next. This is fine. We're creating a single shape. So that only means down yonder. Okay, let's go before here. I am just going to say, what do I want to say? If Tetris dot figure. So if we have a figure, okay, so for I in range, what if we replace our rows and our columns, and instead of saying the entire game rows and the entire columns, we're going to go through 4 by 4 because yes, a Tetris shape has 4 blocks in it. Okay, so yeah, all right. The fix for that, right? I am going to keep this, right? Because like this is going to ensure that we have that in there, right? And then we have our range. I replaced the 4s. So that's cool. That's great. All right. We are looking great, guys. We have the first shape. I really now want to get the arrow keys down so I can move left and right as well as rotate our object. All right. So let's head up and make a method for each of those. Now, we will expand here, right? Because this is truly our event loop. I like to keep my events here in the game loop, but I'm going to make a method for each of these up in our parent class like we discussed here. Okay, so let's do a few things. Let's do move left. So def left. Sure. Okay, this is going to take nothing. We can just take our figure, not Django, figure. You can see my indentation. I keep clicking the semicolon. That's, yeah, okay. Self.figure, I want to go left. So we're changing our x, and we're going to subtract 1. Okay, remember, if we have a collision, so if self-collision, I'm using that method we made, I am then going to take my figure, x, and we're going to plus equal 1. Okay, we can't go anymore. All right. Really, I can just copy this. Because for move right, we're going to do, the same thing. Okay, we have move right. We can now say plus x. And if we get to the end, we will say minus x. Cool. All right. Cool. Very nice. All right. I'm going to actually throw in one more here that I didn't put before. Let's say free fall. So in a Tetris game, right? When you have the shape lined up in the correct position and I hit a button, the shape just falls to the bottom. So it speeds things up for us. So why not just make that here? I'll say free fall for this one. How long can this fall for? That's a question you need to ask yourself. Well, it can fall until it collides with something else. So while we don't have a collision, what did I just say? While. Let's say while not self.collision. So while that is not true, while it's not false, right? There's no collision yet. Then we're just going to take our figure. We want to affect the y. We're just going to say plus equal 1. As soon as that becomes false, our figure then needs to go into the negative. So minus equal 1. All right, that's a little bonus one there. That's good. And the last one, we are just going to call rotate. Okay, now before you get carried away, Josh, why did you create rotate again? This is the second rotate you've created. You see my semicolon again? Gosh dang it. Our first rotate is up in our shape class. This is not related or linked in any way whatsoever to this Tetris class. This is its own unique one. All right, so it's not going to interfere. I'm going to start to close some things up. I'm going to close down the shape class just to save space on here. All right. We don't need init. Grid can go. Shape can go. Collision. All of these can hide. We'll just leave where we're at. Okay, so rotate. How do we rotate? That's the question. Well, I'm going to create a variable, orientation. This is just a variable in the function. Okay, can't access it outside. Orientation is going to be equal to the figure's current orientation. So before I try to change the rotation of the shape, I'm just going to capture the shape's initial state. Where is the shape beginning? Now that we know this, I can really try to rotate it. So self.figure.rotate. Okay, we made the rotate method. This one is coming from our actual figure above. All right, so we're going to try to rotate it. We're going to say if we get a collision, what does that mean? Well, it means the shape was probably touching the walls. Like if I have an L and here's the side, if I try and turn, it can't turn. So if that occurs, I'm just going to say the figure's orientation is equal to the orientation we captured. So it's this one, right? This was the starting orientation. If I have a collision, I cannot change it. I'm just going to keep the shape's initial rotation. All right, that's really cool, right? We have all of these methods done. Now, most of this class is actually completed. Let's head down to the loop and now integrate these into our event loop. Heading down to the bottom, all right, here is our event loop. So every single game, every website, every whatever, everything created by code, the first thing we check for is if we quit, right? So Google Chrome is constantly checking to see if you quit. That's the first event we look for. So I've done that, all right? So if it's a quit event, run equals false, we exit the system. I'm going to redo this a different way here shortly, all right? But I want to carry on this loop, but I'm going to target the events a little differently. I'm going to create an event called keys, and I can say Pygame, not pass, Pygame.key.getPressed. So this variable keys is literally listening for any time I press a key on the keyboard. That's what it's doing. All right. So before we listen for the keys, I'm going to make sure that our game is not over. So if not end, right? Remember, this is a Boolean property. Okay. So if this is not true, the game has not ended, then we can create a bunch of little conditions. If keys, square brackets, now I can list the key I want to target. So for example, let's go with the left key. So if I press the left key, I'm going to take Tetris and we're going to say left. That's the name of the method we made. Okay, just carry on down here. Okay, so elif keys. If I press the up key, let's use that as our rotate. Okay. The last one here, I'm going to do it a bit differently. I'm going to say elif keys Pygame. So I want the free fall to occur of that shape when I press space, but I don't want multiple shapes to fall at once. So I'll be like space pressed. I'll be like true. So I don't actually have this. Let's make this up here, 166. I'm going to say like space pressed is equal to false in the beginning. So just a flag variable that we're storing in here. All right. Cool beans. The last one I'm going to do here, well, let's keep what we have actually, because I want you to see what's going to happen. We have all of our events linked. Okay, so I target the key, okay, and then we link the method we want to do when that key is pressed. You can see everything's happening here. The only thing that is not going to work is our free fall. So the free fall, I'm going to actually move into here. I'm going to say if space pressed. Okay, if the space was pressed, then we can take Tetris and we can call free fall. That also means that space pressed is then going to become false. And what this is going to do is if I didn't press that, then else we keep with our standard move down method, right? So it's just going to drop down. All right, this should be cool. Let's run the code. I can move left. I leave the screen on the left, I think. Yeah, that's a problem. Space, I fell. Okay, let's do that one more time real quick. I know that I have to fix the left side. Okay, so I can press down or I can press space, and it just dropped it. But you can see I can still move. I don't like that I can hold the key, but you know, okay. And yeah, that collision on the left isn't working. Okay, so the first order of business, let's address that. So if the block row is greater than my rows, or my block column is greater than my columns, or my block row is greater than less than no. Oh wait. Call. Does that might be a little better? Let's run it. Try it. Yeah. Okay. Okay. Cool. Oh, I didn't try rotation, but you can see that, yeah, the rotation works. Okay, so I pressed up. Okay, this is cool, guys. Very, very well done. It was falling quite fast, actually. I don't know. Was that too fast? Was that too slow? What if I changed? Let's bump up our counter to 15,000. A little bit slower. Okay. Okay. This is awesome. Guys, the last thing I'm going to do here for my event, where were our events? All right. So in our events, I'm going to give our game one more space just to look and act like a more game. This will give us more interaction. So I'm going to program quit button keys here. And what I can do is, let's say if, wait a second. I'm going to tab this in once. There we go. Okay. So if, let's say keys, so pygame dot escape. So if you press the escape key, what other key? You could choose any key you want here, right? Let's say the Q button. I press Q, that means quit. I'm just going to say run equals false. That will allow me to quit. Now I don't need that red close button, so I could actually go up to the top of my game, and inside our screen in set mode, I could actually now say pygame dot no frame. Cool. Let's run this. Oh, okay, so I fixed my issue I was having too. The issue I was having is I could hold the buttons and they would move. That's fine. But because we put the yada, all these buttons, I made sure it was in my event loop. Originally, I didn't have that. So it still worked, but you saw that I could hold the button, and we don't want that. That fixed that problem. And then the no frame, you can now see it remove the whole top bar. So to get out of this, in development mode, you could click the trash can in your terminal, or now you can just click escape and it shuts the game down. Great, guys. This is awesome. How are you feeling about this game? I want you guys to comment below. Let me know your thoughts. Are you keeping up? Right? Is this a good way for you guys to learn? I want to hear your thoughts. And I want to hear, what game do you guys want to see next? All right? Do me a favor, click the like button and smash that subscribe button if you're still here, because I know you're getting value. I'm having a blast. Let's get back to it. All right, I'm going to close my trash can. Where am I? I'm going to go up to my Tetris class. So boom, right here. I'm just going to clean everything up. So I'm going to uncheck these to keep our eyes focused where they should be. All right. I need remove row. Okay, so I'm about to build that out. And I'm going to actually add in let's do remove row, and I need a method that's going to freeze the shape on the screen. All right, so once it like hits the bottom, essentially, it's just going to like freeze it in that location. So we're about to build out these two here. Let's begin with the freeze one so you guys can actually see and stack the shapes that are coming up. All right, so let's build this out. We're going to say freeze, right? And this is really just responsible, right, for it's going to, when there is a collision, it's going to freeze that item on the screen. So once it goes all the way to the bottom, that's when this is going to occur. Okay, so we can go through all of our dimensions of our shape like we have. And so for I in range, you could copy this from anywhere else we've done it. For j in range for if I times 4 plus j is in our figure image, right? That represents the figure's orientation list, okay? What do we want to do when that happens in order to freeze it? I essentially want to turn that 0 into a number. So hang on a sec. This, okay, so here I have a grid, right? And this is our master list with a bunch of sub-lists, all with zeros. Now, if I change it from a 0, it's going to be 1, 2, 3, or 4, which represents one of these pictures. So if you guys ever played the game like Minesweeper, right? When you click from memory, I'm going to put a picture on the screen to make sure I'm right. But when you click, it displays a number to show you how close you are. And Minesweeper uses a grid. So it's kind of like that, actually. So when I freeze the shape, I want to capture the current color of the shape. So if it's picture 1, what is that? Blue. Okay, so it's going to be blue on my grid. It's going to change that 0 into a 1 to save its place. So if this is true, then I'm going to take my grid, that is our board game, and we're going to say I plus self.figure.y, and I need to access internally again, right, the sublist. We're going to say j plus figure.x. And that is equal to our figure color. Boom, just like that. That is awesome. Okay, so we changed the number in our list. That's fine. That means the shape is frozen. I would like to create a new shape now. There's a shape on the bottom. It's now time for the next one to start falling. Right? All right. Then finally, what's going to happen here? You tell me. If there's a collision inside freeze, what should happen? Well, that actually means we've stacked too high, so our game is actually over. So I'm going to say self.end is equal to true. All right, freeze is done. Take a moment to process what we've done here. All right, we loop through our specific orientated version of the image. So L, which L is it? Okay. And we basically save that position in the grid, but we save it as an integer, 1, 2, 3, or 4. And that number represents a color. So we're changing it from 0, where everything is, into a number. Once we save it, we then create a new shape, okay? And then if we collide, which means we've stacked too high, we hit the top of the screen, ultimately, we say the game is over. All right, so I now need to apply freeze. So I'm going to shut that. Okay, I'm going to apply freeze to move down. Okay, and then as well as free fall is going to get it. So we're going to say self.freeze here. Cool beans. All right, let me shut these up. Let's run the code, and I'm going to attempt to just stack them. There we go. So let's just do boom. Okay, so watch what happens. You can see, watch them vanish. They are stacking, but they're invisible. Boom, did you see that? So they are all stacking. It's doing exactly what it's supposed to do. But the shapes that are stacking, once they go to the bottom, we can't see them. They're invisible. So I need to remind my code to keep these displayed on the screen. So let's escape this. This can be done down in our while loop. So let's go down, boom, 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 all the way down. This looks like a decent place. We will go down here, and we are just going to say for x in range of our rows, for y in range of our columns, okay? We are going to say if our grid, so let's access the first list using x, access the second one using y. Let's change that to say Tetris. I'm not in my class anymore. So if the current number, okay, if the current location on the grid is greater than 0, what does that mean? Well, it's going to be 1, 2, 3, or 4, right? It's not a 0. We're changing it to a color, a specific picture in our assets folder. Okay, so if it is greater than 0, that's great. That means we want to save and display that shape on the screen. Okay, so remember how the shapes were falling and they were invisible, but they kept stacking? Well, that's because this was true, right? The location when the shape was hitting was not 0. We changed the number at the earlier stage. So if it is, let's create a value. Let's create an image, and then let's blit the image on our screen, and let's draw a hitbox for that image. So let's draw a rect. So the value is our Tetris grid x, y. Remember, this is a number. This is an integer. Okay, so the image, let's use the integer we got to access our dictionary of pictures. Right? Value is going to be 1, 2, 3, or 4. That unlocks one of those pictures for us. It's that simple. So what do we want to see on the screen? I want to see the image on the screen. That's wonderful. Where do I want to see it? Well, x times our cell size, and then y times our cell size. Cool. This little hitbox we're going to create around it, let's draw it on the screen. Okay. As I mentioned, the color, it's irrelevant. White. Okay, the rect values, we're going to say y times cell, the cap lock thing, cell, okay? X times cell. We're going to make sure they keep their same width and height, so I'm giving 2 more cells. And then we can say 1, that's the width again. Okay, so let's run it again. This should do this. So keep fallen shapes on screen. Okay, let's save that. Running your code, that is going to keep those shapes all displayed for us. So now we can stack and actually see what happens with that. Okay, so 1. Okay, well, losing the colors there. And you can see, okay, so I did something that shouldn't have happened. Let's fix it. Okay, well, this looks correct to me. So I'm going to go back up to, where did I say, like, if I don't know, freeze. We can see, well, I know that this is going to be correct. So because I've checked that, I'm going to go back and we're actually going to jump. Okay, so it has to be here. So greater than 0, captured. Okay, so let's swap these. Say y times cell, x times cell. Run our code, swapping those values there because that's what the rect is also drawing. So I think the rect is being drawn on top. Yeah, there we go. Boom. Okay, this is cool, guys. What a fun game. Okay. We have our Tetris game coming to life. I'm going to shut that down. Shut down. Let's return up now to remove row. Right, so this, if we get a row, we need to remove the row. Okay, so I'm going to create a method called remove row. Okay, we are going to say, well, first off, we could call this a few times, right? So like if you have 2 or 3 rows in the bottom, you would call this recursively on itself again and again. So the first time we call this, I'll say like rerun is false. I don't want to call it again. I might want to, I don't know. Okay, so initially, no, we don't want to. Okay, now I'm going to loop through. I'm going to say for y in range. All right, so this is going to be interesting. I need to loop through each row and check if it's completed. Now, usually we would just loop through the lists like normal. But because the Tetris game is on the side, I actually want to start at the bottom because that's where most likely a connected row is going to be, on the bottom. And it's going to start on the bottom and loop up from there. So I just need to reverse my range, right? So where do I want to start? I want to start at self.rows -1. Where am I going to? 0. That's the top of my list. And to make it go backwards, I will say -1. That is my step. Okay. So now beginning at the last row, I'm going to create a flag called, let's say completed. Completed. I'm going to assume the first row is completed. I don't know if it is. I'm just going to assume it is. Now that I have assumed it is completed, I'm going to try to disprove that. So basically what I've done is I've assumed one row is completed. I'm now going to take that row and I'm going to check each block in that row. So I'm going to say for x in our range, what are we ranging of? I'm going to start at the left, 0, and we're going to go to the number of columns that we have. If our grid, if our grid, tap y, tap x, so if the current block in the grid is equal to 0, what does that mean? Well, it's not actually completed. I just disproved it, right? Because 0 represents an empty grid, okay? So that's not true if that block represents 0. It should be a 1, 2, 3, or 4 to stay on our screen. Okay, so really all we've done so far is I've just created a Boolean, right? Completed, that's all that happens. Let's now use that. So if completed, if that is true, we can delete, take our grid, delete the y, delete that row from it, okay? But when I delete that, I also need to insert a new row where? At the top. So at position 0, I'm going to insert a new row. What is that new row? Well, it's going to be a list, right? So here for I in range for the number of columns that we have. Okay, so I've just inserted a new list. If I can spell grid, because GERD is not a word, grid, at the top of our list. This is great. Okay, at that point, let's just increase our score. We got a point, right? And what we can do is I can say if my score is divisible by 10 is equal to 0. That means if you got 10 completed rows, you're going to move up a level. So it's going to get increasingly harder. You could say 10, you could say 5. It's up to you on how many rows you want to delete before you move up a row. So if that's the case, let's say self.level starts on 1. Let's add 1 plus equal 1. At the end, I can say rerun is equal to true. And let's just make sure that we are going to say if rerun is true, I want this method to recursively call itself, okay, because multiple rows need to be done. All right. So this is completed. Remove row, all right? I want us to use this inside freeze, right? Because the first thing I want to do when a block hits the bottom is I want to call remove row to check if that row was actually completed or not. All right. Wow, this is great, guys. Comment. Any questions? What's going on? How are you guys finding this video? Is it helpful? Are you having fun? That's what matters. All right, let me shut these down. Okay, so everything looks swell, guys. Really, I could run this and it would take me time to complete a row. Here, okay, I'll run it, I'll skip, I'll complete a row, we'll delete a row. Okay, here we go. Is this it? No, this isn't it yet. Here we go, okay. Ooh, did it? Okay, so I'm glad I actually ran that. Let's go figure out why we didn't move a row. Okay, so let me escape that. Shut down. What I'm thinking here is, well, okay. Let me put 4y. Let's put that inside there. Okay, so now this part, yeah, okay. All right, so let me run that again. Indentation, right? Sometimes I miss that, okay, but it's playing around. There's no error that's given, which is fine, but we still get an indentation problem. What can I do here? Can I do this? Okay, here we go. Moment of truth. All right, look at that, guys. So a whole row was deleted. We are right on track. This is amazing, you guys. So technically you have a working game, right? The game, it's not done. Could be done, but you have a working Tetris game. I want us to display in the bottom of our screen the next shape as well as the score and the level. Okay, so to do this, let us go down. Okay, let me close up. Let me clean up first. All right, let's go all the way down. I can take away this space now. Clean code is good code. Uncheck the red, keeping our attention. Boom. Okay, so honestly, let's go down to the bottom. Okay, let's call this the control panel. This is the stuff at the bottom of our game, the control panel. So in our control panel, I'm going to say Tetris.next. So if there is a next shape, okay, I'm going to go up and we're just going to take these 3 lines. Okay, famous state. We're going to use them here. So make sure your indentation is not like mine. This is amazing. So let's create an image. All right. Let's say our image is our assets dictionary. We're going to tap into Tetris. Next color. What is the next color going to be? I'm going to create an X, and the X position here can be our cell times our Tetris next X. Plus J minus 4. Our Y, where do we want the Y position? Let's say the height of the screen, minus 100, plus the cell. Say so, okay, like this math here took me a while of just playing around with it, okay? Just trying to pinpoint exactly where you want it on your screen is sometimes a pain. Take the Y plus I. That's something, right? Okay, screen dot blitz, okay, image, and we're gonna give it our X and our Y. Okay, let me run this and let's see what we're working with here. Oh, wow, okay. I do not like that. If you can see the issue, then okay. Okay, the issue here, well, okay, so I need to check if it's in the next shape. I was on my current figure so we could have that little rotation. We don't want that, okay? And I need the accurate representation of our next shape as well. So let's check now. So it's supposed to be a square. It is a square. It's supposed to be red. Ah, look at that. Okay. Very cool, guys. So I'm going to close out. That is, I mean, almost brilliant. Okay, really, let's get our score on here. So I'm going to create 2 objects. Let's say score text. Sorry. Okay. Level text. All right, so we've already created 2 fonts. I'm going to say the score text is going to be font 1. I would like to render something. And the level text will be a little smaller. So we have font 2 and we can render something different out. So starting with the score, I'm going to give it an F string. And we're just going to say Tetris.score. I want that to appear on my screen. I always say true for the next one. Okay, it's just like, it doesn't matter. True or false. Okay, and then I'm going to say white. What color do I want the text to be? White. For the next one, we could do the same thing. I mean, score, if you wanted to say level, we could. Okay, and then we could say here Tetris.level. Okay, we're going to give it true, and we are going to give it white. Brilliant. Now that we have those 2, we're going to take our screen. We are going to blit those. So I'm going to blit the score text. The score text needs to be on my screen where? I want it to be in the bottom. So I'm going to say like, I know the width of my screen is 250. Let's subtract the score text width. So I can say get width. And we're going to divide the width to give it a bit of padding by like 2. So that should be, that's 1, right? Yeah. And then I'll say like height minus 110. Okay. The other one will be a bit different. I mean, you guys could put hard numbers in here. I am trying the best I can for code reusability. So if I change my overall game's settings at the top of our code, I just have to do it in that one place. All right. So let's blitz. We want here level text. Okay. And then also we can say 250 minus our level text dot get the width of how big that is. And we can also divide that by 2. And then for the other one, we can say like height this time minus 30. careful, my height is not done. Cool. In the real world, our world, if I run this, we're good. The only thing I want to touch on now is our ending. So like when we lose. Okay, so here is an interesting thing. Is it just from this one? Yes. Did I? Oh, this. It's parenthesis here. Okay. Cool. That's awesome, guys. So, all right, escape that. The last thing, right, is basically like, if Tetris dot end, right? So if that's true, I want to call like a method. I want to like end the game, and I want to do this in like a way that allows me to like reset the game as well. So like a little reset screen. Okay. So to do that, let's go up to our Tetris class. I'm gonna make another method. So okay, there we go. I'm gonna say def end game. All right, so we want to end our game. I'm gonna call this method when we want that to occur. And really, I want to see like a window on the screen that tells me that I can quit the game or I can restart the game to give my user options of what they want to do next. So the first thing we can do is we can create a rectangle. Okay, this is going to be like a pop-up. That's a better name. Pop-up. It's going to be a pop-up window on our screen. All right, so I'm going to create this by saying Pygame.rect. Now this is going to be a hitbox. Okay, so it's the rect class. Where do we want this? 50, 140, that's the X and Y. The width and height. The width can be pretty big. It can be almost our entire screen, but let's not say the whole screen. It's like minus 100. And then the height can be the height minus, our screen is 500, let's say like 350. Okay, so I've created a pop-up box, and I would like to now draw some rectangles on the screen. So Pygame draw rect. I'm going to do that twice. Draw rect. Okay. So I want to have two of these little boxes we just made here. In the first one, where do you want to draw it? Well, it's going to be drawn on our screen. We can say black, and we can say pop-up. I want to draw the pop-up box. The other one is going to be like kind of like the text on our screen in a way. So I'm going to say lose. I want the color red. I think that's red. Pop up. Cool. And then how big is that going to be? I'll say 2 with the width. All right. So we need some messages. We are going to have game over. Option 1 and option 2. Okay, so for game over, we're going to create a font 2. I would like to render. You can just say game over. That's what we want to see on the screen, right? I'll say true. And for my color, I will say white. Okay, that's cool. Because the game is over, we must have lost, right? I will say font 2 again. We would like to render. So let's give the user 2 options. We could be like, press, not emojis, press R to restart. That could be one. We can say true. We are going to say the red color, so we lose. I'm going to copy this. Don't know why. It could be faster for me to type it. I'll say press Q to quit. We already programmed the quit button, actually. We just have to program restart. This is great. So each time we can take our screen, we can blit. I'm just going to copy and paste that 3 times because we need to blit 3 things on this little rectangle. The first one is going to be our game over text at the top. Okay, so where do we want this? Well, let's take our pop-up box. So pop-up dot center X. That's going to be the center of this new pop-up window that we display on our screen. I'm going to subtract our game over minus the width of our game over. And let's divide that by 2. Okay, is that just one location? Yeah. Then our other one is going to be our pop-up
y. So pop-up dot y, and let's add a little bit to it. It's like 20. Wow. I might be able to actually take this and just use that again. So for the next one, we can say option 1. And for the last, well, let's do this one. So let's say option 1 here. Okay, instead of 20, let's increase that to like 80. Okay, and then for the last one, option 2, we just have to increase the final one as well. So we are going to change this to say option 2. And then let's say like, I don't know, 110, 120, 110. Okay, awesome. So let's just test the game over real quick. So if I go down here, where did I put that? If Tetris end, let's say Tetris.endgame. That is the method we just made. Boom, shakalaka. Run our code. Drum roll, please. Okay, so let me try and lose in order to get that window up. Ooh, devastation. Unsupported. So, okay, so I'm going to go up to... Okay. Get with is a method. I did not call the method. I see that all the time. I do that sometimes too, and it's fine. Okay, but we need to call that method. So my division was not the issue. It was me calling the method. Run it. Look at that, guys. So now we have options, Q or R. If I press R, doesn't work. Press Q, well, that's, there we go. It did quit. Okay, it took a moment. Let's just, that's all we need, guys, is our final restart key. How can I integrate that into here? Well, let's go before we quit. Let's just say if keys, Pygame, we are going to say key R. Okay, so if I press the key R, I'm going to take my Tetris object and I just want to initialize it again. This is basically me restarting. Inside, we're going to give it our rows and our columns. That's it, you guys. Wonderfully done. I'm going to run it for a final time and I'm going to stack them for the purpose of resetting our game. R resets our game. You guys have built a working Tetris game in Python here on Code with Josh. Guys, do me a favor. Did you like it? Let me know your questions right before I cut.
If you enjoyed today's episode, guys, of Tetris here on Code with Josh, do me a favor, click the like button and subscribe. All right, I'll see you guys in next week's episode. Until then.